Hello student. In today's session we will discuss about the inverse transformation. So what is the inverse transformation and what is the need of inverse transformation? Okay. So suppose P is a point and it has a coordinate x, y. P is any point and which has a coordinate x and y. We can write its coordinate in a homogeneous coordinate system. We can write this P in a homogeneous coordinate system like x, y and 1. Okay. So what is the need of homogeneous coordinate system we discussed in a last session? So this is, suppose this is a point P which has the coordinates x, y and 1 in a homogeneous coordinate system, and P dash is a new position. P dash is a new position of the point P when some transformation will done on this point P. Suppose it has the coordinates x dash, y dash and 1. So what is the relation between this P and P dash? P and P dash. P is a original position. P is the original position and P dash is a new position. Okay, P is a new position. So we have done some transformation on this point P so that we get the point as a P dash. Okay. Now, so what is the relation between this P and P dash? P dash is equal to TR into P, where TR is a transformation matrix. Where TR is a transformation matrix. So if we consider TR dash inverse, TR dash inverse. Sorry, first of all, what is a TR? TR is a transformation matrix. Transformation matrix, and its inverse. The TR inverse is the inverse of TR, where TR is a transformation matrix. Okay. So if I pre-multiply this equation, suppose this is equation 1. If I pre-multiply this equation by TR inverse, so TR inverse into P dash is equal to TR inverse into TR into P. Okay. If I pre-multiply this equation, I will get this equation. Okay. So multiplication of TR inverse and TR, the multiplication of transformation in matrix inverse and transformation matrix inverse is a unit matrix, and if we multiply any number by 1, then we get the same value. Similarly, if we multiply any matrix by a unit matrix, then its value is remain same. Suppose A is a matrix and it has some value of, suppose, A, B, C, D, and if I multiply this matrix A by a unit matrix, so unit matrix can be written in a I and it has a value 0, 1. Okay. Suppose I take the multiplication of these two matrices, then value or multiplication of these two matrices will be the same as the matrix A. So that here TR inverse into P dash is equal to its unit matrix. It is denoted by I and P, and if you multiply, take the multiplication of this, it is equal to P. So we can write as P is equal to TR inverse into P dash. TR inverse into P dash. Remember that multiplication of these two means, suppose PR inverse into P dash is not equal to P dash into PR inverse. So always remember that P is equal to transformation matrix inverse into P dash, and this is called as the inverse of the transformation. What is the need of inverse of the transformation? Suppose I given that before discussing about the inverse transformation, we discussed the transformation, and suppose P dash is a new position and P is the origin position of the point, and if we given that P is the original position and we perform some transformation operations such as we rotate the point P 30 degree in a counterclockwise direction about the origin, then by using this information we can find out the new position P dash. If we given that the new positions of the point P, then how can we find out the original positions of the point P? So by using the inverse transformation, we can find out the new position, original position of the point P when a new position are given. Okay, so this is the use of the inverse transformation. So what are the different types of the inverse transformations are? The first one is the inverse translation. Inverse translation. Inverse translation. So what is the homogeneous coordinates of the translation matrix? We can denote it as a TH, and it has the coordinates 1 0 0 0 1 0 EX TY 1. So this is a matrix of translation. Okay, so this is a translation matrix. So when we want to find out the inverse of this matrix, so what is the value of inverse of this matrix? The inverse of this is PH inverse is equal to, here we replace this Tx by minus Tx and Ty by minus Ty. To obtain the inverse of translation matrix, we replace this Tx and Tx by minus Tx and Ty by minus Ty. So what is this Tx? Tx is how or at what distance we translate the point P in x direction. Suppose I translate the point P in x direction by 4 units, then this Tx is equal to 4. And we translate the point P by 10 units in a y direction, then this Ty is equal to 10. So this is a Tx and Ty, and inverse of this matrix is 1 0 0 0 1 0 minus Tx minus Ty and 1. So this is the inverse of translation matrix. Okay, so this is the first type of the inverse translation. Then second type of the inverse translation is rotation. Rotation of or inverse of rotation, inverse of rotation. Inverse of the rotation. So first of all, what is the rotation matrix? The value of rotational matrix. The rotational matrix is denoted by R, and it has a value of cos theta, here sin theta, and here 0, here minus sin theta, here cos theta, 0 and 0 0 1. Okay, so this is our rotational matrix. And what is theta? Theta is an angle by which we rotate the any object in counterclockwise direction. We rotate the any object in a counterclockwise direction. Suppose this is our x-axis, this is y-axis, and this is the point P. This is point P having the coordinates x and y, and we rotate this point P at this position. Suppose I consider this is new position P dash, x dash, y dash, and we rotate this angle theta, and this theta is measured in a opposite to, or we measure it in a counterclockwise direction. Suppose this point P is rotated, its new position is, suppose this is P dash. The new position of this point P here is the P dash and has the coordinates x and y dash, so that this theta, in this case this theta is negative because the point P is rotated in a clockwise direction. So this theta is negative in this case. Okay. So notice the value of inverse of this rotational matrix. The value of this rotational matrix, or value of inverse of this rotational matrix, we can obtain by replacing this theta by minus theta. We putting the value of theta as a minus theta. So inverse of rotational matrix is here. Cos of theta is replaced by minus theta. Sin of minus theta 0 minus sin of minus theta, cos of minus theta 0 0 0 1. Okay, so it is equal to cos of minus theta. Cos of minus theta is equal to cos of theta. Means if we put value of cos 30 and value of cos minus 30 are same, so cos of minus theta is equal to cos of theta. Sin of minus theta is equal to minus sin theta. So it is equal to minus sin theta, here 0. Then again, sin of minus theta is equal to minus theta minus sin theta, and minus become plus, so it becomes sin of theta. Cos of minus theta is equal to cos of theta, here it is equal to 0, and here 0 0 1 0 0 1. So this is our inverse of rotational matrix. Okay, so this is our rotational matrix. Okay, now third type is, third part of the inverse rotation is inverse of scaling. Inverse of scaling. So scaling means increase or decrease, or increasing or reducing the size of the object. Means suppose I want to increase the size of the object by, suppose this is an object and I want to increase its size to its double. So its x coordinate will increase by 2 times and y coordinates also increase by 2 times. Suppose I want to reduce it to 1/4. So it reduces to 1/4 in a x direction and also reduces in a 1/4 in a y direction. So in what is a scaling matrix? Scaling matrix. Okay. So scaling matrix is denoted by the S. Scaling matrix is denoted by S, and its value is Sx 0 0 0 Sy 0 0 0 1. Okay. So this is our scaling matrix. Scaling matrix where Sx, what is the Sx? Sx is the we suppose this is my object and I want to increase this object in x direction by 2 times. So means how much times you want to increase or decrease in x direction. Suppose this object I want to increase in x direction by 2 times, then this sx is equal to 2. Suppose I want to reduce this object to its half size in x direction. So the value of sx is equal to 1 by 2. So this is sx is the how much times we want to increase the object in x direction. So this is the sx. What is sy? Sy is the how much times you want to increase or decrease the object in a y direction. So this is the value of sx and sy. So what is the value of inverse of this? Inverse of this scaling matrix is equal to obtain the inverse of this scaling matrix, we want to replace this sx by 1 by sx and sy by 1 by sy. So by changing or by doing these changes, we can obtain the inverse of this matrix. So inverse of this matrix is equal to 1 upon sx 0 0 0 1 upon sy 0 0 0 1. So this is our scaling matrix. This is our scaling matrix. Okay. Now fourth type of the inverse transformation. Fourth type of the inverse transformation is the inverse of reflection. Inverse of reflection. So inverse of the reflection. There are 5 types of the reflection, that is reflection about x-axis, reflection about y-axis, reflection about the origin, reflection about the line y is equal to x, and reflection about the line y is equal to minus x. Okay. So in a case of reflection, we can say that it's about y, about x-axis. About x-axis. So reflection matrix is denoted by R, and the reflection matrix. The notation of the reflection matrix is P M. M reflection about x-axis mx. So it has a value of 1 0 0 0 minus 1 0 0 0 1. So this is the reflection matrix about the x-axis. So inverse of this matrix, the inverse of this matrix is also equal to same, means inverse of the reflection matrix is mx. It has an inverse, and the inverse of this reflection matrix about x-axis is same as the value of the reflection matrix in x about the x-axis. So now about y-axis, so my is equal to, it has a value of minus 1 0 0 0 1 0 0 0 1. So this is the value of reflection matrix about the y-axis, and its inverse also same. The inverse of this matrix is equal to its own value. That is inverse of the about the y-axis. Okay. Now reflection about the origin. About origin. So m of xy. M of xy is equal to, it has also value of minus 1 0 0 0 minus 1 0 0 0 1. Okay. So this is the value of reflection matrix about the origin and its inverse. The inverse of mx y is equal to value of mx y. So this is also equal to same. Now about line y is equal to x. Similarly, this here mx inverse is equal to mx. So mx is the reflection matrix in about x-axis, and its inverse has the same value of both the inverse and this matrix has the same value. Similarly, the matrix about the line y is equal to x, that is line y is equal to x is equal to, means both the inverse and its origin matrix has the same value. Okay, so about the line y is equal to x, its inverse, the reflection matrix about the line y is equal to x has the same value that of its inverse. So these are the some types of the inverse transformation in a two-dimensional. Okay, so these are the types, and it is enough for today's lecture. In next lecture we will go through some numerical and next type, that is inverse of composite or concatenated matrix. So thank you.